Hello everyone, let's solve our next problem. The point on the circle x squared plus y squared plus 6x plus 8y equals 75, which is closest to the origin, is at what distance from the origin? Okay, so yeah, we are given an equation for a circle. It's not clear whether the circle contains the origin or is sort of far away from the origin, but regardless, there will be a point on the circle which is closest to the origin, and my instinct is to just find out what that point is. I don't know if that'll be exactly the best way of doing this, but another thing I want to do first is I want to rearrange the equation so that it's written in more of a standard form for the equation of a circle. The way it's given here, it's not easy to identify what the center or the radius of the circle is. So I'm going to rearrange that, do some factoring, and that will hopefully make the problem a bit easier. Okay, so after some rearranging, manipulations, and factoring, I find that the center of the circle is at coordinates -3, -4, and has a radius of 10. So in fact, you know, the point -3, -4 is at a distance of 5 from the origin. And if the radius of our circle is 10, then our circle is large enough that it actually contains the origin. Drawing a picture here might be the best way to try and figure out what our answer is. So there's the center of the circle there at the point -3, -4. Like I said, this is a distance of 5 from the origin. It's just a 3, 4, 5 triangle. But the radius of the circle is 10. So, you know, if I actually drew the circle on this figure, it would sort of extend. It'd be way out here like this. So what I think I will do to try and find the point which is closest, the point on the circle which is closest to the origin, I'm going to draw a straight line. Wait, what is the best way to do this? If I draw a straight line from the origin, or from the center through the origin, that will intersect the circle out here somewhere. But will that be at the closest point? It has to be, right? Because a line from the center to the edge of the circle will intersect it at a right angle. What's going on here? Yeah, I think that works. I'm not sure why I'm having this weird mental block about whether this will work or not. But that's what I'm going to do. I'm going to find the equation of a line which connects the center of the circle to the origin. And I'm going to find where that line intersects the circle. It will intersect the circle in 2 points. There will be one intersection in that direction and one intersection in that direction, but it'll be clear which of these two that I actually want. Once I have that point of intersection, oh wait, no, there's a much easier way to do this. If I extend this line in this direction, I know it intersects the circle. The circle has a radius of 10. Okay, here's how we're going to do this. I know exactly where the point of intersection will be. It'll be at the point 3, 4. It'll be right there. Okay, because we know that the point, the center of the circle is at this point, which is a distance of 5 from the origin. And the radius of the circle is equal to 10. So if I extend this line through the origin, I have to travel a total distance of 10 before I hit the circle on the opposite side of the origin. And I know that this distance then has to also be 5. Because, you know, then I have a total radius of 10. Okay, so I'm saying that the distance of the closest point on the circle to the origin, it is a distance of 5 away from the origin, and not only that, we know what the point is. It is going to be the 0.34. 5 is one of the multiple choice options given for the correct answer, so I'm fairly confident in this. There might be other clever ways of doing this, but anytime you have a geometrical question like this, drawing a picture is almost always a good way to go. If I find a mistake or if I have anything more to say about this one, I'll put them down in the description. Thanks for watching.